So just to go over what we're going to be doing today, we're going to start off with Richard Smith giving us a bit of background about why we are running this webinar today. Then we'll have Liz Fletcher from Birdwood Energy to discuss the alternative power options that are available. We have a pre-recording from Joel Vendroot, who's the general manager at Tall Trees. And Tall Trees is a nursery, and they've got a backup battery and solar system for their nursery. And so in the video, Joel will explain a bit about why they've invested in that. And then we've also got Bruce Manaveld here today with us, who's a dairy farmer from Gippsland. And so he's got a generator as a backup power option to operate the dairy. So we'll hear from Bruce. And then we'll have an opportunity for questions after that. So I will pass over to Richard to give us a bit of a background about why we're running this webinar today.
Thanks, Sarah. So I'm Richard. I'm in the dairy and the recovery teams. So the reason we developed this webinar was some of the findings from the 1920 bushfires, as well as it was reinforced by the Gippsland storm event, which occurred in June, as well as the localised power outages in October that occurred in Gippsland. So generally, when we're talking about power outages in these sort of settings, we're either talking about bushfires or storm events. So if we can have the next slide, Sarah. So the loss of any power, to agricultural businesses can cause a failure of critical infrastructure. And for animal businesses, we're talking about things like livestock water systems, fences, milk harvesting equipment if we've got dairies, automated feeding systems, heat or refrigeration, irrigation systems, if we're talking about horticulture businesses, as well as loss of packing lines and loss of cool rooms. So just to highlight, power outages can have a critical impact on dairy businesses. So if we lose power and we can't milk dairy cattle, their milk producing cells will begin to shut down after 36 hours. So that will have a critical impact to your bottom line, to your business, as well as to the welfare of your animals. In a trial conducted in NZ by Dairy NZ, 25% of cows that weren't milked for 7 days developed mastitis. Now, if you think of a 200 cow herd, at least 50 cows of them developed clinical mastitis. And another proportion of them developed subclinical mastitis. Now, the rapid change from 12-hour milking to 24-hour milking can have critical changes on animal behaviour, which is directly linked to animal welfare. So things like changes in eating time, rumination, gait, they can have critical impacts. So most people, when they think about horticulture, they don't think of the impacts that power outages can have on horticultural businesses. So we can have failure of irrigation systems, failure of GPS base stations. Now, this will directly impact those farms running controlled traffic operations. So you won't be able to do anything like, you won't be able to do spraying, planting, or harvesting. It can cause failure of packing lines and cool rooms. So these are the sort of impacts that we're talking about that can occur for agricultural businesses when we have a power outages. So today we'll be discussing what backup systems can be employed to make sure that we can operate those critical infrastructure during these power outages. Back to you, Sarah.
Awesome. Thank you for that, Richard. I'll stop sharing my screen and I will let Liz share her screen. So I've just realised, Liz, that I forgot to get a bio for you today. Yeah, I'd like to welcome Liz from Birdwood Energy to present about backup power options available to farmers.
Thanks so much, Sarah, and thanks, Richard. That was a really interesting rundown. So very quick intro on myself. So I've been working with customers in the energy space for a bit over 10 years now, across Victoria, New South Wales, and even a little time in WA. Have spent some time in networks, in retailers, and now find myself at an organisation called Birdwood Energy, and we really focus on helping customers make investment decisions. We don't sell hardware, which is an important piece, but very much about helping customers make investment decisions and then making sure that they actually work for them over the life of that investment. So the purpose of this is obviously running through how dairy farmers can set yourselves up for outages when and if they may occur. So the team have asked me to run through these 5 topics. So we're going to run through the challenge of reliability, which Richard's already tapped into slightly, look at the tech options. So whether we're looking at batteries or solar or backup generation, how we actually size that system based on your needs, some things to think about as you go through the process of installing. And then probably, to be honest, the most important piece is about how do you actually operate that system safely and in a way that actually works for your operation. So if we jump into the challenge, so Richard spoke about what causes outages, but some background on what's actually happening on the energy system. So you would have heard in the news, Australia is leading the way in the uptake of what we call behind the meter renewables, so solar. So we have more homes with solar on the roof than anywhere else in the world. In fact, when you add it all together, it's bigger than any of our power stations put together. What that's doing is meaning that we have this really cheap energy, to be honest, almost too much energy in the middle of the day. But to move it around, we need to build more network. And that is actually pushing up the cost of network. So we're seeing a real shift in energy costs and also the way we operate. So, and then the trend that's playing out in businesses like you guys is that you're choosing to do what we call insourcing reliability. So you would be thinking about solar, you'd be thinking about like backup generation and those things, just because if sometimes the investment case or the business case for investing behind the meter or on your site is actually more cost effective than paying higher network costs, and you can actually bring down the cost for everyone. And so that's where we start playing with this construct of, in energy, we talk about a trilemma. So we are trying to balance reliability with affordability and sustainability. Having spoken to a few in the dairy industry, there is an increasing demand from providers of managing carbon intensity of production. And as you move through the supply chain, there are possible carbon tariffs and things like that that will start to emerge. And so understanding that net zero thing is an important thing when you start making decisions about assets that are going to be on your property for 10 plus years. And so they're important things to think about. So if focusing very core on the dairy sector, there is an amazing document done by Dairy Australia focusing on energy, and this is a graph that came out of there, which highlights why, while solar is great and cheap and can deliver some really good long-term benefits, its generation profile isn't as useful for your sector as it can be for other sectors. And so that's where we start having these kind of more interesting conversations about how we leverage other pieces of technology. So in that document, which I'm sure Sarah can share, or you've probably already had a look at, there's some work around how some of the energy can be moved into the middle of the day, but this is the challenge really. And this is the challenge we're seeing in the whole sector. The most expensive periods of time for energy now is where there's the highest demand. And unfortunately, as an industry, the dairy industry correlates to those points in time at the moment. So that's pretty much why we can't just solve the world with solar. So today, we're really going to focus on how we can leverage the cheap solar output from solar, new technologies and which are increasingly very well tested of batteries, and the more familiar technology of generators with a couple of new additions, which we're starting to see come through. And I know we've got some case studies coming through as well. So this is a diagram that we think about at Birdwood of how we put together an energy strategy. We really believe that you need to think about all these different pieces before you commit. But when we focus on a backup system, we really focus on these 3 pieces. So while this is a text-heavy slide, I think the interesting thing to think about when you're looking at a backup system, it needs to really work for you on the days that there is a storm, or there is a car that runs, a truck that runs into a power pole. It needs to work for those days, but it also needs to work the whole year round, and it needs to pay. It needs to pay back. It needs to be commercial. So the kind of biggest difference when we balance out between a battery solution and a generator solution is that a battery, and similar to solar, is very much automated, right? It uses technology to charge and discharge. It's really simple to implement. Your people don't really need to do anything, but it all is all dealt with there. Whereas generators, I would assume a lot of your sites actually already have generators. But you understand that requires a bit more legwork, but you're probably much more comfortable with it. You're used to navigating those pieces. The key thing to note is that a lot of the systems, and we're going to hear from people today, are starting to move towards this hybrid piece, and really it's about understanding the mix that you want based on your carbon targets, your cost targets, and really what you want out of this system as well. So we need to think about what are your requirements for information sharing, what are your requirements for financial impacts, which brings us to step 3, sizing our system. So a key thing to understand, well, there's 5 big questions. First question is always, have you done all your energy efficiency initiatives? So we don't want to be building a system that's going to be powering anything that's wasteful. If you have available land that's not being used for other purposes or doesn't have another value, solar can obviously provide benefit to you now and into the future, and is effectively the fuel stock for a battery system as well. So understanding that is a really important piece. And then as we move through question C, we get to one of the hardest questions when we have conversations with customers, is about what is the actual maximum energy demand that you're going to need during that outage. The reason why we ask that is, I think about a system almost like a bucket with a big pipe on the end. And so we need to know how much you're going to draw from the system during that outage. And that's the power of the possible system. And then the second piece of information that we really need to figure out is how big do you actually need the well to get you through those periods in time where there's an outage. Now, the benefit of a solar system, and also obviously a generator, is that it can top up the system during that period of time when the sun's shining or when you refill the tanks. But during a storm, you may have issues with supply for fuel, or the sun may not be shining. So these are really important things to think about when you start navigating these questions. And so then we get to question E, which is, how are your energy needs going to change over the next 10 years? So the energy market's changing. Your market is changing. Are you planning to expand? Are you planning to shrink your operations? These are really important questions to decide on technologies, because the technologies are changing. It's really important that you take what we tend to call like a very much a plug and play model, so that you're not stuck with a particular system that won't interact with another one if you choose to expand it. And so that question is very, very pivotal, because you may end up with a solution that doesn't keep you in power during an outage in 5 years' time, because you've not necessarily planned in that timeline. That's not to say you can't expand something, but it's something to keep in the back of your mind. So then installing your system. Now, personally, this is the bit I find the most hard to navigate, especially when we're looking at new types of technologies or emerging technologies like battery and automation and some of those things. My biggest piece of advice would be to find an experienced installer and get them to work with your existing electrician who knows your site. All the work we do with customers, and I've ever done with customers, you all know your sites and you've got an electrician who's installed your systems, and they have everything drawn up in an SLD. Even if it's on the back of a napkin, it doesn't matter. It will save you a lot of time and trauma if you can get someone who knows how to deploy these systems to work really closely with someone who really knows your site, and then they will talk together to get you the best outcome. Would suggest that you should be asking whoever's delivering your system to propose plans for installation and operational maintenance. You should be really understanding how the system is going to work if your farm is going to expand, and also really understand any performance and uptime guarantees. This is, at the end of the day, you're doing this to meet an emergency need, so it needs to work when it needs to work, and you need to understand what the service standards you're receiving are. Then if we move to kind of a more operational perspective, these systems can actually deliver revenue for you outside your outages. And so I would very much suggest that you should speak to whoever does your energy contracting or your energy consultant or even your retailer to make sure that you're getting paid when you should be. And you can be, that system can be helping bring down energy costs for everyone as well during those peak times when you're not using it. And then the kind of follow-up piece is just making sure that your system has a strong data function, so that as carbon and all of those things come to the fore and we all need to report on those, you can do that really easily without having to run around in circles or pay a consultant. It will just save you a lot of stress in the long run. So then we get to the fun bit, to be honest. So operating the system, as I said, it's really important that you know your system's going to work when that outage happens. So batteries need to be cycled daily to keep them in good maintenance. That any automation system or standard off-the-shelf product will automatically do that. But there are a bunch of technologies. We have an optimizer that we built with one of the universities. There are other products on the market who can program a battery to do what you need. The same for generators. Generators, as you probably already know, they should be run monthly and they need to be serviced on a quarterly basis. Batteries don't really need a lot of maintenance. It's really just a container, but their location is the most important, because at the end of the day, it's a box of chemicals. So it's very important that's in a safe, cool location. So you're managing any of the risk there. So the one thing I would just put forward is that if you're going to invest in a backup system, which the financial benefit can be quite high, I would very much recommend that you make sure it's not just a backup system, because your system can be delivering value to you 99% of the year, and that can actually pay back the cost during the outage. And that can pay for maintenance and all of those types of things that you would have to do anyway. So in conversations I had with generator suppliers and batteries to do this, to pull this together, they definitely said that they're seeing a big trend towards generators and batteries to be put in with the technologies to work during an outage, but that are actually running to supply power on a daily, if not more, hourly basis. So I think the dual purpose element there is really, really quite important for us to think about. So that's where the presentation finishes at this point in time. I would definitely suggest that backup systems are really valuable in terms of the commercials. We're working on a project with regional communities in Victoria, across Wodonga, Healesville and the Surf Coast at the moment, and the communities are really thinking about how they can do this, and the councils are thinking about how they can do this, even to do as simple things as charging phones during bushfires and storms. So your industry is not the only one thinking about this, but it's definitely something that everyone has on the top of their minds at the moment. So I will leave it there. I'm happy to chat to anyone through the questions, and I look forward to hearing the other presentations. Thanks so much, Sarah.
Thank you for that, Liz. Alrighty, so that was very insightful, Liz. And we're now going to, unfortunately, Joel from Tall Trees was unable to make it today, but earlier this week I was lucky enough to be able to have a chat with him, and we were able to record a little snippet of him discussing the systems that they have at Tall Trees, which is a nursery that do street trees, etc. So I will just share my screen now. Make sure I have my sound on, and we'll hit play in a second to hear from Joel.
Joel from Tall Trees. We're a production nursery growing plants and trees for the commercial and civil landscape divisions. We're located on 20 acres of land down the Mornington Peninsula. And basically, I just wanted to talk to you guys today about our solar setup and why we put that in place. Some of the reasoning behind that, and why it's become a really valuable part of our infrastructure here. So the main reason we decided to invest was it actually comes back to water for us. So for a nursery, irrigation and getting water to plants is the #1 concern above all else. Without that irrigation, we could lose the whole nursery in sort of a 24 to 48 hour period, depending on the weather conditions for that day. So to run those pumps and to get that water out, power security was really vital for us. We have tried other things in the past. We had generators in place. We even tried auto start generators that would kick in, but we found them a bit cumbersome, quite large and sort of in the way. And we found that the auto start quite unreliable. So if ever we had hot days, we still had to send people to the nursery to ensure that the irrigation had been through and that everything was supposed to be doing what it was supposed to be doing. So that's the main reason we went down the path of putting solar. The other was a bit of an advantageous situation. We just built a very new structure that lends itself perfectly to installing quite a large system. So we sort of put 2 and 2 together and put that system in. Really brief rundown in the system. We have a 35 kilowatt battery setup with 30 batteries and around 120 panels on the roof. We did an estimation of our system at the time. Our daily consumption was around 60 kilowatt hours. So we've built the potential to around 140. That's during daylight hours with the solar. As I said, the battery system is around 35 kilowatts. Now, the impact of power outages for us is, as I briefly touched on, it's crucial that we're A, aware of them, and B, are able to do something about them. We can't just sort of close the doors and hope for the best when the power goes out. We still need to irrigate. We still need to get water to 20 acres of trees. So, and we also have quite a large administrative operation here at Tall Trees. So when that power does go out, computers go off, the internet shuts down, and our phones don't work. So there's a multifaceted reason why we wanted to secure that power supply. So now that we've had it in place now since 2018, and it's been almost flawless since. We have had quite a few power outages, including some recent storms, and we were able to continue operating both administratively in the office and with our irrigation, trusting that system. The solar runs everything during the day, so straight from the panels, and we get 2 irrigation runs through. Over summer especially, we need to irrigate at night and very early in the morning because we have recycled water, so our staff can't be out in the nursery during those hours. So we actually need the batteries for that first run at 4 or 5 in the morning before the lights turn on. So that's been crucial for us to have that battery set up rather than just depending on the solar itself. Now that we are sort of a few years into this, a couple of things that I wish I put a bit more time into was perhaps a bit more of an accurate forecast of our growth. We've ended up putting on quite a few bits of machinery contributing to our automation systems here. Whilst they are handling the load, we are still growing. So there is probably going to come a time in the not too distant future, we're going to have to expand the capacity of the storage unit and possibly putting more panels on the roof as well. But that being said, we did just put another 5 kilowatt system just to run the office. So we've taken some of that strain off from the main irrigation supply chain to sort of help. It was a small thing we could do to really expand that capacity without going above and beyond up on the roof. It's quite a tricky spot. Look, I hope you guys have got something out of this presentation. It's if anyone ever has any questions, the guys can send you my address, and I'm happy to help out.
All right, so that was our video from Joel there, and it was great to see that some of those things that from Liz and those key points around making sure you size your system to be for the future have really come out there, and also some of the people aspects around the generators versus the solar and battery system have been an impact for Joel and his team there at Tall Trees. So now I'd like to welcome Bruce Manaveld to speak to us. So Bruce is a dairy farmer in Gippsland, and he has a generator system run by PTO that is used during power outages to operate the dairy. So over to you, Bruce.
Thanks, Sarah. Yes, Sarah asked me to come along to this. Sarah asked me to come along and share my experiences with what happens when our power went off, what has happened to us when the power went off and why we put the system in. So a little bit short history about us. We're a dairy farm up at Birdwood North in South Gippsland, running sort of 330, 340 cows through a 28 unit herringbone. It's quite a few other bits and pieces attached onto it, creating more and more power all the time. But why we were so keen, we bought the place that didn't have a generator. Or when we looked at the place and bought it, had a setup, a hydraulic setup to run the vacuum pump to actually milk. But when we actually moved in, that had been taken away. You know, people who sold the farm had taken it with them, which is fine. That didn't stress us too much. So, but we organised to put a generator in this place within the first sort of 8 months of being here. And the reason, before we bought this place, we were share farming over at Shady Creek near Warrigal. And in the last year there, the power went out for about 40 hours in the middle of early September. So right in the middle of right towards the end of our calving period in peak production. We missed, so the cows didn't get milked for 24 hours. And in the meantime of that, the neighbour had managed to get a generator hooked up to his dairy. So we ran them up there about 30 hours after being milked the last time, put them through his shed at 9 o'clock at night, and then ran them home again. The power came back on the following day, so we brought them home, milked them through our own shed again back then. I thought that's good. So we lost sort of 10,000 litres then. We thought, oh, we'll get away with this, not too bad, looking all right. And then, so day and a half later, when I went to get the cows to milk them the next morning, rode into the paddock, opened the gate into the paddock to get the cows, turn the bike in and go, cow down the gate with milk fever. That's a bit of a problem, but not unusual, like it happens. So treated her with milk fever, gave her a couple, I always carry some 4 with me, so gave her a couple of packs of that. Got back on the bike, set her up and got her sort of settled, and we got back on the bike to go and get the rest of the cows. And as I swung the bike around, I saw another one. I got 2 just inside the gate. This isn't good. So as I was swinging the bike around with the headlights to put the 4-in-1 pack, organised to get the 4-in-1 packs into her, I saw another cow down. This isn't looking good. So quick flight around the paddock on the bike. There's 14 cows down with milk fever, 3 dead cows, and a whole heap of others that were staggering around all over the place. Sorry. So it turns out we basically just stressed the cows out big time from not being milked for 24 hours and then sending them to the neighbour's shed and bringing them back and then trying to fire them back up again. And the whole thing had just tipped the herd over. And yeah, that was a fun morning, that one. We in the end, we treated about 50 cows that morning, possibly more. I think we ended up in another 20 or so over the next day or two, just basically through classic milk fever symptoms, and fixed them all, packs of 4-in-1. But Sunday morning, 5 o'clock, didn't have enough 4-in-1 packs to do all that. So rang the vet, got him to just basically bring out a couple of boxes of 4-in-1, a couple of like 40 or 60 bags of 4-in-1 to treat the cows we didn't have enough for. I also rang, the parents were 20 minutes away. I rang them to see if they had any. They didn't have any, but they then got on and rang the local supply store and got some more packs out of them. So we ended, I don't know how many packs we ended up, went through probably 100 that morning. And yeah, it was great fun. We ended up, so all up, it cost us about 12,000 litres of milk, 3 dead cows, and we started giving made to the rest of the herd for the next week just to make sure to try and get over it, try to get them through it as best we could. There's mentioned earlier about cell count issues and herd health problems. Well, that's obviously a herd health problem, but the cell count, we actually got away with the cell count. It didn't move apart from the milk that was sitting in the vat already. It didn't get picked up for another 24 hours. It blew that cell count out, but the actual cows got over the cell count without a major hiccup. But yeah, and we did the sums on what that outage cost us, and it was more than putting a generator in. Just that 1 40-hour outage, and we just paid for the generator. So yeah, and we were share farming, so we hadn't done anything about it. But we had mentioned to the farm owner a few times that it'd be a good idea to get one in, and by the day, so halfway through the power outage, the farm owner's gone, I think when the power comes back on, we might put a generator in. So that was a win. That was good. And that showed up a couple of months later and it's all installed, and I don't think we ever actually used it as such to run the milking shed. Yes, then when we bought this place, we thought, well, one of the first things we wanted to get done was put a generator in so we could milk when the power went out. And because we had one put in out there, we sort of knew what we were looking to do. And my brother's an electrician, so we leaned on him a bit for ideas on what needed to happen. And we spoke to the electrician we were using up here to put things in and whatever else. And we ended up putting in an 85 kVA PDO powered tractor powered generator. The reason we went with a tractor powered one because I'm not a mechanic, and I figured the first thing that happened is when I needed the generator to work, it wouldn't work, and I wouldn't know how to get the diesel motor going to get it started. So I just thought, I'll just tractor rig, it'll be working much easier. We have a lot of trouble trying to if you ask trying to get an electrician to tell you how big a generator to put in, they don't like giving you a direct answer because there's a lot of, it's not just as simple as running around the shed and adding up all the motors, the power usage of all the motors, because you need to cover the startup surge as well. Because when every electric motor starts up, it'll run a surge of power, which will trip the system out, and that's probably right for all of the big motors, but all the small electronics sort of slowly more and more creeping into dairies. They don't like that sort of thing happening to them. They get upset when the power jumps around a bit. So we yeah, went that way. Well, the other thing you need to consider is if you're going to put a PDO powered generator in, you need to consider the size of the tractor, because the tractor needs to be big enough to then run the generator. You can use a small tractor to run a big generator as long as you're not drawing any power off it. But the moment you start turning more and more motors on, that's when the tractor won't cope. So you need to get the tractor size to suit the generator. Or the other option we did at Shady Creek before we had a bigger tractor was to start isolating various bits of the system out. So we set it up so the hot water service couldn't run while the vacuum pump was running. The 3 big drawers in a dairy are the vacuum pump, the milk vat, and the hot water service. So if you isolate one of those 3 out, you can get away with a smaller power to run it when you need it to run. And we also made sure that we had extra. There's the 85 kVA one we put in, we got spare power in it to run more things as we need to add them in later on, if we need to add them in later on, or motors get bigger, or all those sort of things. But yeah, so that's basically why the power went out this year again for 40 odd hours this year in June, when the big storm came. One of the big storms came through Gippsland. We had 3 this year so far, but the one that came through in June took it out here for 40, nearly 50 hours this year, and we just backed the jet tractor up and off we went. No stress whatsoever. We didn't have to worry about hurt health. We didn't have to worry about any of that sort of thing. It just not having to worry about the stress of knowing what you're going to do and how you're going to cope when the power goes out. It's just that relaxes. It just takes so much pressure off. It's great. So yeah, I wouldn't run a dairy now without trying to have some way of milking the cows. Even if you just milk the cows and dump the milk, you still need to have some way of being able to milk them. And I'm reasonably fair feeling around that at some point it's going to be part of our milk quality requirements from the factories, or milk animal welfare standards from factories, that we're going to need to be able to milk the cows consistently, whether you're doing it once a day or twice a day or whatever. There's going to be a requirement at some point, I reckon, from animal welfare, that we need to be able to milk them consistently to avoid issues. So yeah, I think that's sort of basically all I've really got to say, is that it's very important there's a generator or some way of milking, and a generator that's big enough to cope with everything and has got room for future increases in herd size or shed size, probably more important. I think that's important. Hey Sarah, if there's any, I'll hang around. If there's any questions at the end for any of us, that's great.
That's fantastic. Fantastic, Bruce. Thank you so much for sharing your story. Yeah, it's great to see. It's really unfortunate to see the event that actually saw you guys start implementing a generator, but it's great to see that you guys have implemented a generator and the benefits that you're seeing with just being able to milk through and continue operations on farm when that power goes out, even through that June storm event that we did have in Gippsland. So now I'd like to open it up for questions, and we've had a couple start to come through the chat box. If you can please send your questions to myself, just so that no questions do get lost, because last webinar I had ran and organised, we did have a couple of questions get lost. So if they can come through to myself, that just makes it a little bit easier, because the presenters aren't always able to check their message chat for the questions as they're answering other questions. So we have had a question here come through. What scope is there for hedging energy prices as a form of insurance to fix the price of electricity and protect against any adverse movements farmers could make more use of hedging, forward buying and selling? Any thoughts? I actually think that this one's probably a bit out of the scope of today's webinar talking about power outages. But Liz, I will pass it over to you to see if you do have a response to this question.
Yeah, hedging energy prices is just like fixing a loan from the bank, right? So you can choose to have a variable or you can have a fixed. Any standard retail contract is effectively an energy hedge. A backup power system, to bring it back to this conversation, effectively acts as a physical hedge against future energy prices. So Bruce's story about installing that system on his site, he could, in theory, he's got a set price for energy. He knows what it costs him to operate that system. That is a physical hedge for energy prices. So there are lots of different ways you can do it, but yeah, it's definitely an option and something you can speak to a consultant or even a retailer about if that's something you think is important for your business.
Thank you for that, Liz. Liz, you mentioned before that you got a question in your chat earlier come through there about solar working during a power outage.
Yeah, so this is something that's really exciting. So Australia has actually developed much of the technology in solar. Actually, I think 90% of solar panels originate from technology that came out of UNSW. But since that happened, the inverters have changed a lot. And so we now have grid forming inverters and a bunch of new pieces of technology that enable your solar to keep working if there is an outage. So I think if that's something that your system is struggling with, it's definitely worth a chat with whoever installed it to see if you could upgrade your inverter to enable you to use your solar energy during an outage.
Awesome, thank you for that, Liz. I have also forgot to mention earlier that we do have a case study on our Energy Smart Farming page about tall trees as well, which gives a bit more detail and different details around the tall trees story around their solar and battery system as well.
Sarah, I've just got there's a question here for Bruce. What did you do about hot water heating, as your hot water system is meant to heat to the right temperature in your system?
Yeah, you've got to, because we can now actually run the whole lot at once because the system's big enough to cope with it, we can run the hot water service. And our hot water service is probably set up slightly different to everyone else's. It's actually run by an analog meter in the dairy. So I can run it in the middle of the day. It's a slightly dodgy setup. I don't think it's quite legal, but it's how it was done 30 odd years ago. So we can actually run the generator whenever we run the hot water service whenever we want. So now we can set that up. Now we can just sort of, while we can milk, we can run the hot water service at the same time now. But in the short term, if you run a cold wash through your dairy, it's not going to be an issue. But if it's off for a week, you're probably going to start causing milk quality issues. And if you explain that to your factory at the moment, they're probably going to be okay about it because what's the why. But yeah, still hot water service is very important, I think. So just as important as getting the milk cool. And yeah, so we're lucky. I think you probably can set it up that way as well, regardless. I'm sure there are options to do it. But yeah.
There's a lot of technologies that can do this now.
Yeah, because it always used to be ran through the meter.
Yeah. In South Australia now, they've transferred, as you say, the meter even on households because there's so much excess solar in the grid. Everyone's 10 o'clock standard automatic timer has been moved to 10 o'clock in the morning rather than 10 o'clock at night. So yeah, absolutely. So what you're doing is the way in which, who knows, is whether that's the way it should be done, but what you're doing is exactly what everyone can be doing as well.
Hi, Liz. I've had a question come in regarding full load or partial load. If you're you only want to run part of your system, what are the pros and cons there?
So it comes down to be honest, the physical setup. And Bruce, you probably went through this process when you were designing your system in how the actual wiring was done. Is that something you explored through your process?
Yeah, I guess that was part of the reason that the last farm got set up to isolate the hot water service, because we couldn't run the whole lot in one go. And yeah, ours is now just an all on or all off. But yeah, you could have, if you'd got into the switchboard, meter box, whatever, you could have isolated various parts, but out to turn have bits and pieces that didn't run through the generator, I guess.
Yeah, 100%.
We didn't. We went the other option, thought we'll just make sure we can run everything and we can run it easily.
And I think that's the decision, right? Understanding your kind of risk profile. If you've got things that don't need to be run in an outage, then you can isolate. Like, for example, if you had a house, for example, that was connected to the same circuit, you might have like the TV and those things, which don't need to be able to be turned in an outage, as an example, right? I'm sure your kids would say otherwise, but but there are things that you could put on a second circuit, which would mean that you're not draining out of your generator or your battery system unnecessarily loads. But they're just decisions you can make.
Thank you for that, Liz and Bruce. We have had more of a comment here about making sure that you are selecting reputable suppliers. So making sure that you've got suppliers that are potentially known and trusted, and that that can be reliable, so that if you do have any issues with needing service, or there is an issue with the system, that they will be there so that they can come and they can make sure that that you get those services that you need to make sure that the system is reliable for you, especially when we're talking around power outages, because as Liz and Bruce have said, we do want this system to work. And as well, Joel also mentioned in his video, we do want this system to work when the power does go out. Yeah.
100%. I like, there is no, all of the systems that we have seen go in, we've worked with a local provider and installer, but also the on-site electrician, whoever. Bruce, it was your brother in your circumstance, but whoever knows the site, right? Because you want to be able to call them and say, hey, the thing, it's not turning on, right? Otherwise you'll be in a bit of strife.
The other thing too, Liz, is what's your thoughts, and Bruce, what's your thoughts about farmers if they want to, say, hire a generator? What things do they need to do beforehand to make sure it's an easy connection, so that it's quick and easy in the times where there is a power outage?
I guess you got at some point you still got to have a shed, somewhere to plug it into the dairy, into your system somewhere. The one we had put in at Shady Creek was actually a portable one, so we could actually pick it up and take it around the farm and do welding or something somewhere else on the farm with it at other times of the year, or when the power wasn't out. So that was useful, but we still had to get a plug wired in. So presumably there'll be a standard plug within the industry for that sort of thing. I'm not 100% sure, but I imagine there's a standard. It's probably just a standard three-phase plug, is it? I'm not sure.
Yeah.
40 amp, whatever they are.
Something to that point, I think, yeah. The one thing I would say is that if you wanted to hire something for outages, chances are you'll be paying a lot more because everyone else wants one because there's an outage. Yep. So that's a kind of cost benefit analysis to think about in how you go about that, because there are only so many generators in the lot. But it's an interesting model, and I think even with batteries, mobile batteries are becoming a thing. There's, after the bushfires, a lot of the councils have thought about them from a community perspective. So yeah, it's a really interesting model to think about.
Richard, is there any insights from what you've seen with the recovery efforts post the Gippsland storm event with farmers and their access to generators? Was there issues with farmers accessing generators in that situation?
Definitely. We've seen it twice this year. Two dominant occasions, obviously in June, but also in October. If you're trying to hire a generator at a time when everybody's without power, you run into a couple of risks. Firstly, people tend to get the first generator that they can find because they need to access it immediately. So they haven't put the groundwork into what size the system is. So we had a couple of instances where hire generators were actually destroyed. So you've not only got to pay the higher cost, but you've got to also pay the replacement cost, which in most instances is full retail for the price of the generator. Plus you have a whole range of training each time you hire a generator. It might have slightly different operating procedures to turn it on or turn it off. So you've got to factor that into consideration. Firstly, we've also got to have your system set up so you can actually plug the generator in. So you've got to have a pre-installed safety switch. You don't want to get to a situation where you need but you also need to hire an electrician at the same time to wire your system up to actually plug in that hired generator that you're going to return in 2 to 3 days. So these are the instances that I've seen, and I've spoken to people who have sort of run into the situation where they've had to hire a generator. This is what they're faced with, and they've sort of now got this thing that they've spent the money, they've purchased it, they've either blown it up or they can't use it until another electrician arrives and wires it in, or wires the system for safety switches and transfer switches at a time when everybody also wants electricians. So it is one of these things where it's doable, but you've got to pre-plan how you're going to do it. So you'll have to do the groundwork first. If that's your risk management plan, is you're hiring a generator, you've got to make sure that you have planned out that your system, that you know what sort of size generator you need, that your dairy shed or whatever you're going to plug into it is wired correctly to be able to take that generator. You've got transfer switches, you've got safety switches, and you know the operation procedure. So that's sort of the things that we've seen if you're going to hire a generator.
Fantastic. Thank you for that, Richard. That is great to get some of those points and from those experiences of other farmers during the recent events and power outages that we've had. We also have had a question back on comment back on that last question too from a colleague, that we also need to factor in that you may not have access to your property to get a generator or an electrician in on site. So if we've had a severe weather event, might have some flooding, might have trees down, we might have roads that are damaged that or if we've got fire, we may not be able to access the property. So that's something to be aware of. So how can the phone companies solve power outage issues? We can make power with Jenny's, but no internet. I think that's a bit of a tough question, maybe out of scope for today, but
it's such an interesting
stuff.
It's such an interesting question, right? Because it's a really interesting question. And publicly Telstra have been trying to figure out how they can use, because they obviously have generators and batteries at all of their points. But it is a challenge. It's definitely something that's being worked on through these processes. And it's also something we're looking at with the Surf Coast on their microwave towers down that way, about how you can deliver power, because you're totally right. Like what happened in Malakuta during the bushfires is exactly what happened. So people are very aware and working on it.
Yeah, and there's just a bit of backup there to that question, saying that they need to operate some devices by internet, such as irrigation controllers, etc. So just a bit of wrapping up. like to say a big thank you to Liz for her presentation today, Bruce for sharing his experiences and why they've gone and put in a generator and the benefits that they've had from that and just being able to continue operation. And also thank you to Joel, who was not able to join us here today, but was able to do a pre-recording for us. And also a thank you to Richard, who has been involved in developing this webinar with me, heavily involved, and for presenting today, as well as other contacts as well.